So in this video, we want to take a look at a couple of specific kinds of sequences. First, arithmetic, and second, geometric. Let's first define what an arithmetic sequence is. A sequence is arithmetic if there exists a number d called the common difference, such that a sub n plus 1, so the next term in the sequence, the n plus 1 term, equals the nth term, a sub n, plus d, where d is this common difference for any integer n bigger than or equal to 1. So let's just take a look at a couple of examples. So for the following arithmetic sequences, identify the first term a1 and the common difference d. So these are very straightforward. So for this first one right here, a1, the first term is 4, and the common difference d is simply 5. If I notice, that is the difference between terms in this sequence, so very straightforward. In this second one, the first term, a1, is 34, and the common difference d is the difference between successive terms. Well, d in this case then would be negative 7. Each successive term is 7 less than the previous one. This third sequence, the first term, a1, is 2, and the common difference. Well, let's see, from 2 to 5 halves, by the way, this 2 right here, you can write 2 as 4 over 2 if you need to. From 4 halves to 5 halves, that's a difference then of simply 1 half. So the common difference is 1 half. Now, let's define the nth term of an arithmetic sequence. The nth term of an arithmetic sequence is given by a sub n. So the nth term is the first term, a1, plus n minus 1 times d. So to find the nth term, I start with the first term, a1, and then I add to that n minus 1 times the common difference d. So let's use that to perhaps do this next example. Find the 14th term of this sequence. So fairly straightforward. So I first need to notice that a1, the first term, is 4, and the common difference d is 3. So the 14th term is going to equal the first term, 4, plus 14 minus 1 times the common difference, d, in this case, 3. So this would equal 4 plus 13 times 3. That's 4 plus 39. That is 43. So the 14th term in this sequence is 43. Now, the follow-up question is in the previous example, which term is 301? That is, find n if a sub n equals 301. So if a sub n equals 301, then, well, what can I say? I can say 301 equals a1 plus n minus 1 times d. 301 equals a1, that's 4, plus n minus 1 times the common difference d, which is 3. And now I simply wish to solve this for n. So solving for n. So 301 would equal 4 plus 3n minus 3. And then if I solve this through, I get n equals 100. So which term is 300 first? N equals 100. Excuse me, which term? The 100th term is 301. Now, let's discuss the sum of the first n terms of an arithmetic sequence. So if I have an arithmetic sequence, then the sum, which I will write capital S subscript n. So S sub n equals n over 2 times a1 plus a sub n. So a1 would be the first term, an would be the nth term. So I add those together, multiply it times n over 2. So let's do this. Find the sum of the first 1,000 natural numbers. Okay. So if I take a look, the first 1,000 natural numbers, this would be 1, plus 2, plus 3, all the way out to 1,000, okay? That's what I'm interested in. I'm interested in the sum, okay? The actual sequence itself is just 1, 2, 3, 4, all the way out to 1,000. So let's identify A1. The first term is 1. And the common difference D. Well, the difference from 1 to 2 is 1, from 2 to 3 is 1, so the common difference D in this case is 1. Thus, S sub 1,000 is equal to 1,000 over 2 times the first term is 1 plus A sub 1,000. Well, the 1,000th term is just 1,000. And so if I run this through, I would get 1,000 over 2 times 1,001. And this should look strikingly similar to a formula that we've seen many times to compute the sum of the first n natural numbers. It's simply n times n minus 1 over 2. And that's exactly what I have right here. And so if I run this through, I should get a sum of 500,500. Okay. Okay, let's move on to this next example. Find the sum of the first 15 terms of this sequence. So what I want to find is I want to find 4 plus 7 plus 10 plus 13, and I want to find it for the first 15 terms. Okay, so let's notice that A1 equals 4, that's the first term. The common difference D is 3, that's the difference. Okay. So first we compute A sub 15, okay? And how do I find the nth term of the sequence? This is A1 plus n minus 1 times D. So this is, you got to recall. So this would equal A1 plus 15 minus 1 times D. So A15 would be 4 plus 14 times 3. So the 15th term would be 46. Thus, S sub 15, that's n minus 2 times A1 plus A sub n. So this is 15 over 2 times A1, that's 4, plus, in this case, A sub 15, that's 46. So S sub 15 would be 375. That would be the sum of the first 15 terms in this sequence right here. Now, let's pivot and discuss another type of very common sequence that is encountered in mathematics, and that is something called a geometric sequence. So a sequence is geometric if there is a number, which I'm going to call R, called the common ratio, such that a sub n plus 1 equals R times a sub n. Or you can write R as a sub n plus 1 over a sub n. And this R right here is called the common ratio. So, for each of the following, determine the common ratio. So let's just simply ask this question as I progress through this sequence. How do I get from 3 to 6? Times 2. How do I get from 6 to 12? Times 2. How do I get from 12 to 24? Times 2. 24 to 48? Times 2. So in this case, R equals 2. Each term is 2 times the previous term. Okay, what about the next sequence? I'm looking for the common ratio, R. Okay, how do I get from 1 to negative 1/2? Well, from 1 to negative 1/2, it looks like I multiply by negative 1/2. From negative 1/2, if I multiply him by negative 1/2, negative 1/2 times negative 1/2 is a positive 1/4. If I multiply 1/4 by negative 1/2, I get negative 1/8. So my common ratio R equals negative 1/2. Okay, thirdly, for this sequence right here, okay, so I could ask, what do I multiply one term in the sequence by to get the next one? Or I could simply hunt for the common ratio outright. R equals the n plus 1 term divided by the nth term. So let's look at R. Let's compute it outright. Let's do 1060 divided by 1000. That should tell me what I multiplied by from 1000 to get to 1060. Well, if I divide those out, I get 1.06. And notice, if I do the same thing again, if I do 1123.60, so that's the third term, and divide that by the second term, so that is 1060, if I'll divide those out as well, I'll also get 1.06. So what I'm doing to get from one term to the next is I am multiplying by 1.06, and so that is my common ratio R. Now, just like we had a formula for the nth term of an arithmetic sequence, I also have a definition or a formula for the nth term of a geometric sequence. So the nth term, a sub n, equals a1 times r to the n minus 1. So let's use that to find the seventh term of this sequence. So first let's verify that it's geometric. Okay? So this sequence is geometric. With r equaling, well, let's check. How do I get from 4 to 20? Times 5. From 20 to 100? Times 5. So the common ratio R is 5, and A1, the first term, is 4. So I desire A sub 7, which would be A1 times R to the 7 minus 1. So A7 would equal A1. That would be 4 times R, in this case, is 5, to the 7 minus 1, that is 6. Remember, I have to do order of operations. I have to do the 5 to the 6th power first, and then multiply that times 4 to give 62,500. So that would be the 7th term in this sequence right here. Now, in the same way that we had a formula for the sum of an arithmetic sequence, we also have a formula for the sum of the first n terms of a geometric sequence. So S sub n, the sum of the first n terms, if I have a geometric sequence, equals a1, the first term, times 1 minus r to the n over 1 minus r, provided r is not 1. I can't have r be 1 because then I'd be dividing by 0. So let's use this to answer the next example. Find the sum of the first 7 terms of this sequence. Okay, so this sequence is geometric with a1 equaling 3 and common ratio r. Well, let's check. How do you get from 3 to 15? That's times 5. From 15 to 75, that's times 5. From 75 to 375, that's times 5. So the common ratio r is 5. So S sub 7 would equal a1, that's 3, times 1 minus r, that's 5, raised to the 7th power over 1 minus r, which is 5. And I'm going to use a tool for this one right here. Maybe. So if we have 3, parentheses 1 minus 5 to the 7th power, divided by, and I'm going to put the denominator in parentheses as well, that's just 1 minus 5. Or you just punch in minus 4. And if I run that through, I get 58,593. And so this would be the sum of the first 7 terms of this sequence, where I start at 3 and I'm multiplying each successive term by 5.